Hey everybody, Mr. Reeves with you yet one more time. And today we are looking at a review of Unit 1 with a focus on Module 3. So just a reminder, Unit 1, the only unit actually we've done so far this year, is called the number system. We began with Module 1 where we added and subtracted integers and did some problem solving with integers. Remember, an integer is any whole number and its opposite. So it starts at 0 and then goes 1, 2, 3, 4, 5, 6, 7, and so on. And then it goes also backwards, -1, -2, -3. But there are no fractions or no decimals with integers. So we were just adding and subtracting integers. And we did some problem solving there, like I said. We did multiplying and dividing integers, did some problem solving there, and then we've been spending a lot of time recently with rational numbers. And remember, a rational number is any number that can be written as a over b, where a and b are integers and b is not equal to 0. All right, so I'm going to skip over to the Module 3 quiz, ready to go on. And I'm going to go through some of these problems with you. And then we'll also be doing a little bit of review of some of the other material from Unit 1. Excuse me, the quiz you will be taking will cover Module 3 as well as some of the things from Module 1 and Module 2. All right, so let's go ahead and take a look. All right, 3.1, we learned how to change fractions to decimals and decimals to fractions. So it says write each mixed number as a decimal. So just a reminder real quickly, all right, when you have a rational number, there's three ways that you can represent a rational number. You can represent it as a fraction, right? A over b. You can represent it as a decimal, right? Which would be like A point B, C, D, something like that. Or you can represent it as a mixed number. And of course, all of these here are examples of mixed number. In a mixed number, you have a whole number followed by a fraction. A whole number followed by a fraction. Actually, could be an integer followed by a fraction as well, because it could be positive or negative, right? So the easy part here, if we're going to write these mixed numbers as decimals, is 4 in a mixed number is 4 in a decimal. 12 in a mixed number is 12 in a decimal. And 5 in a mixed number is 5 in a decimal. So the question simply becomes, what is 1/5 as a decimal? What is 14/15 as a decimal? And then, of course, what is 5/32 as a decimal? All right, so just a reminder, decimals are powers of 10, right? So when I look at 1/5, I say, well, I can quickly make that a power of 10 by multiplying the top and bottom by 2, right? And when I do that, I get 2/10, all right? So 1/5 is equal to 2/10, and of course 2/10 is 0.2, right? Because remember, when you have a decimal, all right, you have the ones place, and then you have the tenths, and then the hundredths, and then the thousandths, and so on. So this right here is the tenths, and then we have the hundredths, and then we have the thousandths, right? And this is the whole number place. And then if we kept going, that would be tens, and that would be hundreds, and so on. All right, so 4 and 1/5 is quickly changed to 4.2, and that's just some mental math. Now this one's a little bit harder because 15 does not go into 100 evenly, right? So at this point, and the same thing here, we're going to want to divide. So when you have a fraction that is not easily converted, or when you have memorized, you want to divide. So we're going to want to take the numerator and divide it by the denominator. On this one, we're going to want to take the numerator and divide it by the denominator, all right? Okay. Now, what we've said is it's okay for you to use a calculator on that. All right, so I'm going to use my calculator here, and I'm going to do 14 divided by 15. Now, before I even get my answer, I know that this has to be smaller than 1, right? Because 14 is less than 15. And when I do 14 divided by 15, I get I get 0.93 repeating, okay? So again, it's okay to use a calculator to change a fraction to a decimal. For this year, we're allowing that rather than having you do it by hand. All right, so then I'm going to do the other one, and I'm going to do 5 divided by 32. And again, it's a good idea before you do it to know what to expect. I know that this is smaller than 1. In fact, I know it's very much smaller than 1, right? 5 over 30 would be 1/6. So I'm looking for a number that is even smaller than 1/6. So in my calculator, I'm going to do 5 divided by 32. And when I do that, I get 15625. 15625. I'm just going to write it here. 15625. And again, it was 0.15625 when I divided, but because I had that 5 there, that 5 was there. Okay? All right, so in order to change a decimal, again, these are mixed numbers, but the second part after it is a fraction. In order to change a fraction to a decimal, if you can just change it to a multiple of 10, a power of 10, you can do that, like 1/5 became 2/10. Otherwise, just divide the numerator by the denominator. By the way, we could have done 1 divided by 5, and that would have worked as well. All right, so that's the first part of Module 3. All right, then we talked about adding rational numbers. Now, this is where we have to remember what we had learned about adding integers. All right, if we add a positive to a positive, it looks like they all look like pluses, don't they? A positive plus a positive is a positive, right? A negative plus a negative is going to be a negative. Remember we did the color tiles, all right? Yellow plus yellow is just more yellow, and red plus red is just more red. Now, when you add a positive to a negative, you don't know what it's going to be. It depends on what do you have more of and how many more do you have, okay? So if we take a look at this one right here, we have 4.5 plus 7.1. Well, they're both positive, so I know that a positive plus a positive is going to be a positive answer. And the question is, what am I going to get when I put those together? So I'm just going to go 4.5 plus 7.1. And this one's not bad at all. I don't even have to carry. 5 plus 1 is 6, right? And 4 plus 7 is 11. And I simply get 11.6. All right? I get 11.6. All right, now here it's going to get a little bit more complicated. All right, because 1 is positive, right? And 1 is negative. So this is where I said we don't really know. But now we say, what do I have more of? Or which one of these has a greater absolute value? And do you agree that 5 and 1/6 has a greater absolute value than negative 3 and 5/6? I have more positives, so I know that this answer is going to be positive. But the question is, how much more do I have? And that's where then I have to subtract, okay? All right, now we've learned some different ways to do that. If you did those iReady lessons, what we did was we took this apart and we broke it up and we said, well, 5 and 1/6, I can write that as, let's see, I can write it as 4 and 5/6. Now, if you're going, why 4 and 5/6? Because I have 3 and 5/6 here, right? And this is 5 and 1/6, which means I need 2/6 more. All right, do you guys see that 5 plus 2 is 7? So this would be 4 and 7/6, but 4 and 7/6 is just the same as 5 and 1/6. All right, so if you did it that way, then you would go 4 and 5/6, right, minus 3 and 5/6. That would give me 1 and 5/6 plus 2 more 6, right? And what does that give me? That gives me 2 and 7/6, or 3 and 1/6. All right, now if you're going, that didn't make any sense to me, Mr. Reeves, can you do it a different way? We could do it the traditional way where we borrow, right? We say, okay, I have 1/6, but I need to borrow, so I go here and I make this a 4. Does this look familiar? And then I add 6/6 to this and I get 7/6, right? So here we go. There's that 4 and 7, 6 we were talking about. So 4 and 7, 6 minus 3 and 5, 6. Well, 7, 6 minus 5, 6 is 2 sixths. And 4 minus 3 is 1. So I get 1 and 2 sixths, right? But what should we always do? We should always simplify 2 over 6, right? Both of those are divisible by 2. And when we do that, we get 1/3. So the answer we're looking for is 1 and 1/3. Okay? So again, when you are adding, if the signs are the same, you just get more of them. If these had both been negative, then I simply would have had negative 11.6. When the signs are different, you say, what do I have more of? Do I have more positives or more negatives? And how many more do I have? Which means you're going to subtract. Okay? All right, what about subtraction problems? All right, we went over and over and over and over again that subtracting is the same as adding the opposite. All right, subtracting is the same as adding the opposite. So right here I have negative 1/8 minus 6 and 7/8. I'm going to make that plus a negative. And right here I have 14.2 minus 4.9. I'm going to make that plus 4.9. All right. So now this isn't bad at all because I've got a negative 1/8 here and negative 6 and 7/8. And they were nice enough, by the way, to give me common denominators. We didn't have any here without common denominators. We're going to have to find some that don't have common denominators, huh? So they're all negatives, right? So a negative plus a negative is more negative, all right? If I put these together there, I have a 6 whole number. I don't have a whole number here. So I get 6 and then 1/8 plus 7/8 is 8/8. Well, isn't that weird? Negative 6 and 8/8. But you guys know what 8/8 is. 8/8 is what? 1. So this is negative 6 plus negative 1. So the answer is negative 7. Negative 7. Okay? So because we had subtracting a positive, we made it adding a negative. We put them together. We got negative 6 and 8/8, which is the same as negative 7. All right, and now here we have 14.2 plus 4.9. All right, we're going to add those together. When we're adding or subtracting decimals, we line up the decimal. All right, this time we are going to have to carry. 2 plus 9 is 11. Carry the 1, right? 4 plus 4 is 8, plus 1 is 9, and we get 19.1 for that one, okay? 19.1 is the answer we were looking for there. All righty. Let me check real quick before we go to multiplying and dividing. Let me see if I can find an example where we do not have a common denominator. All right, rational numbers here. All righty, forgive me here for this delay. All right, common denominator. Here we go. All right, this one does not have a common denominator. All right, real quick, by the way, this one, let's do this one real quick. That we do have a common denominator, but we're adding. We say, what do we have more of? We have more negatives, right? How many more negatives do we have? Well, 5, 6 minus 1, 6 would be negative 4, 6, right? I have more negatives because here are 5 and there's only 1. And 5 minus 1 is 4, but it's negative. But again, we want to simplify. Both of those can be divided by 2, and we would get negative 4 divided by 2 would be 2, and 6 divided by 2 would be 3. So the answer to this one would be negative 2/3. All right, but here's one that does not have a common denominator. The denominator here is 2. The denominator here is 4. So if you say, what is the smallest number that 2 and 4 both go into? It's 4. Do you agree? So the second one is going to be the same. So if I want it to be a 4, what do I have to do? I have to multiply by 2, right? So I get 3 and 2/4 minus 2 and 1/4. Remember, subtracting is the same as adding the opposite, right? Although in this case, it kind of just makes sense just to do a regular subtraction problem. Here we go. I don't even have to borrow on this one. This is nice. 2/4 minus 1/4 is 1/4, and 3 minus 2 is 1. Okay, so just a reminder, if you're going to add or subtract, if you don't have a common denominator, you do have to get that common denominator, unless you're doing it on the number line, in which case you don't necessarily have to have a common denominator. Okay, let's take a look at multiplying and dividing rational numbers. Okay, so just a quick review, right? A negative times, sorry, what's that, Mr. Reeves? A negative times a negative is a positive, all right? A positive times a positive is a positive, and a negative times a positive is a negative, or a positive times a negative is a negative, right? Probably should have used dots here instead of X's. Alrighty, how about there? Really fat dots. All right, so that's something we need to remember. All right, you also need to know if you have an odd number of negatives, the answer will be negative, and if you have an even number of negatives, the answer will be positive. Okay, so for example, in this case, we have 1 negative, so the answer is going to be negative. Here we have 2 negatives, so the answer is going to be positive. All right, here we go. So 4 times negative 7/10. So when you're multiplying, you just multiply straight across, all right, with fractions. And then you can either multiply and then simplify, or simplify and then multiply. And if you've watched any of my previous videos, you know I recommend simplifying rather than multiplying first. So 4 does not go into 10, but 2 goes into 4 2 times. 2 goes into 10 5 times, right? So do I now have on the top? I have a negative times 2 times 7, and I get negative 14. And on the bottom, I have 1 times 5, which is 5. So I get negative 14/5. All right, now negative 14/5 is an improper fraction, and that answer is perfectly acceptable. But if you wanted to make it into a mixed number, you could say 2 goes into 14. Sorry, excuse me. 5 goes into 14 2 times, with 4 remainder out of those 5. Okay? All right, but a fraction answer would be probably the preferred one over the mixed number. But hey, what if we wanted a decimal answer? They didn't ask for it. 4/5, it is something we need to be able to do. Remember, I did that problem previously. I want it to be over 10, right? If I multiply by 2, I get 8/10. So there we go. That would be a correct answer as a decimal. That would be a correct answer as a mixed number. And that would be a correct answer as a fraction. All right. Right here, I've got negative 3.2 times negative 5.6 times 4. All right. So again, these are decimals, although this is a whole number. I'm going to go ahead and do this part first. So I'm going to do 5.6 times 4. And again, I'm not going to pay attention to the signs anymore because I already know the answer is going to be positive. All right, so here we go. 4 times 6 is 24. Carry the 2, right? 4 times 5 is 20. So I get 2, 2, 4. And then remember what you do. You look after the decimal and you say, how many numbers are after the decimal? And it's 1, and I get 22.4. And again, you can also just estimate, right? All right, this is close to, well, 5 times 4 would be 20, and 6 times 4 would be 24. So I know it has to be between 20 and 24, so that has to be 22.4. So now I'm going to do 22.4 times 3.2. And again, I'm not worried about the signs because I already know it's going to be positive. All right, here we go. 2 times 4 is 8. 2 times 2 is 4. 2 times 2 is 4. And then we're going to put that 0 there as a placeholder. 3 times 4 is 12. Carry the 1. 3 times 2 is 6. Plus 1 is 7. And 3 times 2 is 6, and we didn't carry 1. All right, so then we're going to add an 8, and that's a 4, and a 2 makes a 6, and a 4 and a 7 makes 11. We carry that 1. All right, and we get 7168. All right, and we look how many numbers, how many digits are after the decimal, and it's 2. and we get 71.68. Again, if you estimated, right, 22 times 3, that would be 66, right? So I know it has to be in that ballpark, all right? So it makes sense that the decimal would be there, okay? All right. Just a reminder, when you're multiplying with rational numbers, with fractions, you don't need a common denominator. Multiply straight across the top and simplify, or better yet, simplify first. All right, let's go ahead and actually see if we can find a couple more multiplication problems that we can do for practice with fractions. Well, there's some integers. All right, let's get to some fractions. There's adding and subtracting. One more page, Mr. Reeves. All righty, here we go. All right, so I think this is something that we really need to make sure we have nailed down super duper well. All right, so this is a multiplication problem. How many negatives do I have? I have 1, 2, 3 negatives, so I know my answer is going to be negative. This is a multiplication problem. How many negatives do I have? I have 1 negative, so I know my answer is going to be negative. All right, now we're going to multiply straight across, but before we multiply, we're going to see, can we simplify? Well, that 5 divided by that 5 is going to be 1. That 2 divided by that 2 is going to be 1, right? I should probably put the little ones here. And then I look across. What do I have straight across the top? 1 times 1 times 1, which is 1. And again, I'm not worried about the positives and negatives because I already got the sign at the beginning when I started. And at the bottom, I have 1 times 1 times 6, which is 6. So I get negative 1/6 as my answer. All right, what about this one? Here we go. That 5 divided by that 5 is 1. Looks like that's all we can do here, huh? All right, so on the top I get 1 times 1 times 3, which is 3. And on the bottom I get 1 times 7 times 4, which is 28. I almost wrote 4. 7 times 4 is 28. So my answer to that one is a negative 3/28. All right, so that is how you multiply with, whoops, I typed in the wrong page number. Let's try this again. 1, 1, come on. 1, 1, 1. Here, I was trying to make it faster. All right, how about 101? Maybe that's better. I didn't, I typed in the wrong number. Okay, so that's multiplying. Now we're going to divide. All right, so when we divide with fractions, that's where we do keep, switch, flip, and then multiply, or if you prefer, KSFM, right? So I'm going to take this division problem and I'm going to rewrite it as negative 19 halves times 7/38, okay? And then I'm going to multiply. But before we multiply, we're going to say, okay, can I simplify? All right, now 2 doesn't go into 7. And you may not have known this, but 19 does go into 38 2 times, right? 19 is really close to 20. 20 times 2 would be 40, but 19 times 2 is 38. All right, then remember, a negative times a positive, or a negative divided by a positive, is going to be a negative. And on the top I get 7, and on the bottom I get 4. By the way, the rules for dividing are the same as the rules for multiplying as far as the signs go. All right, so a negative times a negative is a positive, a negative divided by a negative is a positive, and so on. So all those other rules we went over for multiplying are the same for dividing. All right, okay, and then I'll tell you what, we'll get to a few more dividing problems in just a minute. Let's do the decimal problem here. All right, a negative divided by a negative is going to be a positive. And then I'm going to have to do 3.3 divided into 32.01. Again, 32.01 is my dividend. 3.3 is my divisor. Do you remember what we said we do on these? We move that over one spot, right? So that's going to become, our new problem is going to be 33 into 320.01. 0.1. All right, so that's the problem we're going to be doing. All right, so 33 does not go into 32, does it? All right, so this one right here, 33 times 10 would be 330, so I'm thinking 9. All right, so let's try it. 9 times 3 is 27, carry the 2. Okay, 9 times 3 is 27, we get 29. Look at that. All right, so now we're going to have to borrow. So 10 minus 7 is 3. We're going to have to borrow again. All right, and we get 11 minus 9 is 2. So we get 2, 3, and then we bring down the 1. All right, so, gosh, this is kind of sloppy up here with my carrying. So this is a 9, and then I'm going to put a point, okay? So we are doing 33 into 231. All right, so let's see here. Well, again, 33 times 10 would be 330. 3 times 8 is 24. How about we try 7? 7 times 3 is 1. Carry the 2. Look at that. It comes out perfectly. All right, so we get positive 9.7. Positive 9.7. And if I were to do a quick check on my calculator, if I did 3.3 times 9.7, I should get 32.01, and I do. Okay? All right, so let's skip over and do a couple more division problems. I should pay attention to this page and see if I can actually go there directly next time. All right, I went too far, didn't I? All right, I want to do dividing integers. No, where did it go? All right, there's adding and subtracting. So the next page should be, well, see, it's not my fault. They just don't happen to have any dividing rational numbers. They do have dividing integers. All right, since we're here, a negative divided by a positive would be a negative, and 56 divided by 8 would be 7. A negative divided by a negative would be a positive. Let's see, 5 goes into 13 2 times, and 30, so that would be 26, right? This one right here, a positive divided by a positive would be a positive. And then we go back like this, okay? And again, we move that decimal over one more time, and we're going to get 15 into 345. All right, so we'd say 15 goes into 34 2 times. 4, bring down the 5. 15 goes into 45 3 times, and we would get a positive 23. All right, tell you what, I'm going to go ahead and stop this video here because it's getting kind of long. And in my next video, I'm just going to do some problem solving with rational numbers. All right, so just to review what we have done. All right, we have done, let me go back to, let's see if I can get it right this time, page 101. All right, we have done changing fractions to decimals, right? We did adding, subtracting, multiplying, and dividing rational numbers. All right, so in our next video, I'm going to do some problem solving with rational numbers. All right, I hope this video was helpful to you. As always, you can always email me and ask me for more help if you need it. All right, thanks for watching, everybody.